Here's an introduction to radians. I'm going to talk about it through thinking about wheels and rotation a little bit, thinking about how that has to do with angles and pizza. So let me start with, I want to go fairly quickly through a few problems, and I want to approach them in a way that I've seen students want to do them, and I'm going to massage that and kind of push that into a way that involves radians, because people don't tend to naturally fall into radians, but they fall into something that's closer than you might think. So here's one problem. I've got a wheel, like a bike wheel or something, a little, let's say a little bit smaller than a bike wheel. The circumference is 40 centimeters. That'd be a very small bicycle, I must admit. Okay. And it turns exactly once. In other words, one revolution. Okay, so here's our picture. And it turns around exactly once. Okay. And I've got like a thorn, maybe it's a bike tire, and I've got a thorn, not a torn, a thorn, and I want to know how far did that travel, just in terms of that curvy distance around, how far did it travel? Hopefully, that's a pretty easy question. It goes one circumference. And it's supposed to be a super easy question. So it's going 40 centimeters. Okay. But the punchline is really important, that one revolution of a rotating object buys you one circumference of travel of some object that's on the edge. If it's something inside, it's going along a smaller circle with a different circumference. So be careful about that. And the radius in the center doesn't move at all. Okay, so that is something that people tend to discover on their own, and it's the start of this whole process. Okay, second question, not about a rotating wheel, but it's about a pizza. And I happen to know the circumference of the pizza. And it happens to be 40 centimeters. Again, not a very big pizza. Okay. I eat the whole pizza. And the question is, how much crust did I eat? And the crust I want to think of as really, really thin. It's a very skinny crust. And the right way to measure the crust is how much length of crust. If I put a tape measure on the crust, how much crust did I eat? Well, that's again exactly just one circumference of this pizza. And you're just getting, it's going to be 40 centimeters. Okay. So a whole pizza or a whole revolution just gives you one circumference in either case. Okay, those are supposed to be pretty trivial, or at least that the calculation was trivial. And then we're just going to try and get a little more complicated from that. Okay, so problem 3. Again, let's say I have a circle. Let's say it's a wheel again. Let's go back to a wheel. I'll keep going back and forth. And it's 40 centimeter circumference. And now it only turns 1/3 of a revolution. So here's my wheel, and it turns 1/3 of the way. That's about over to here. Okay, and again, there's a thorn in the tire. And how much distance did it travel? Hopefully, you might want to pause the video, but hopefully you're seeing the answer. And I'm going to bring in a letter. We want like a distance letter, but it turns out that D gets used for various other things in various places in this stuff. And it turns out S is the distance. And because it's the length of an arc, a piece of a circle, it's called arc length. Just a terminology for curvy distance around the edge of a circle, okay? Or around any curve really, but here it's a circle, okay? And hopefully it's pretty clear that that's just going to be 1/3. Or you might want to separate out the units. Okay, 40/3 centimeters. And it's exactly equivalent. I'm not going to redo it like I did before. It's exactly equivalent to say I ate 1/3 of a pizza. And how much crust? Well, that's 40/3 centimeter worth of crust. Okay. So if you know the circumference of a circle and you measure how much of the circle you've either rotated or eaten as in units of revolutions, well, in other words, you're measuring it in terms of units of circumferences, then you just multiply. How much of a revolution times how much do you get from each revolution? One circumference, and you're done. So that would be great if every circle problem was like that, but that's not quite true. And I'll turn off my alarm, which was telling me to make this video, actually. Okay. So now a slightly more complicated problem. Let's keep going with a wheel of circumference 40 centimeters. And now it turns. And now let's think about how you would describe partial rotation. Another way to describe partial rotation is I look at like a spoke. Maybe this is a bike tire again. I look at a spoke and then in the before picture, and then I look at where it is after. That makes an angle. And let's say we use what is the most familiar way of describing angles, which is degrees. Or another way to say it, so it turns 45 degrees. Or an alternate way of saying it is I ate a slice of pizza, and I know you don't do this much in the pizza restaurant, but you could compare your slice of pizza to somebody else's to see who's getting more food by taking a protractor and looking at that wedge and looking at that angle of that wedge, okay? And that's going to give you an idea of how much pizza you have. Okay, so now how much, again, we want to know how far did the thorn go in one version of it, or how much crust, okay? Well, one really quite decent way to do it is to try to reduce it to the previous problem. That's what mathematicians tend to do. Can we just re-express this in different units in terms of circumferences? Okay, well, 45 degrees, okay, how much of a circumference is that? That's going to be 45 degrees over, it looks like 450, doesn't it? Make sure that's a degree mark. Over 360 circumferences. Because one circumference is going to be, or one whole revolution is going to be 360 degrees. And that happens to be an eighth. It's not too hard to see that a quarter would be 90 degrees and an eighth is that guy. Okay, and now we know the value of C, so it's going to be 40 centimeters over 8, or 5 centimeters. Okay, so the trick was to take a measure of how much of a rotation or how much of pizza we had that's in this funky unit degrees that doesn't perfectly align with the idea of circumferences, and we just converted it to a circumference by comparing it to 360 degrees. Okay, that could plausibly be the way that mathematicians prefer to work, but it's not quite. And the only difference between that and radians, basically, that's the start of this of an introduction to the study of circumferentians. And radians are you do the same thing, but you give a privileged role to the radius of the circle instead of the circumference. And the only thing that introduces is the fact that there's going to be a factor of 2 pi, because the circumference of a circle is 2 pi r. Remember, it's not pi r squared. That's the area. That has units of area because you square the radius. So be careful not to confuse it with that. Okay, so here's problem 5. I give you the radius. Okay, so we're gonna introduce radians as an official concept in just a sec, but let's see what would happen if we try to use our original method, and it's gonna be just a little bit clunky. Okay, the previous one with degrees was slightly ugly. We had to bring in this 360 and stuff like that. We actually had to do a calculation, as opposed to the previous ones where it was just the calculation was right in front of us. Here we're gonna get it even a little clunkier, and we'll see that radians kind of move the clunkiness around a little bit. Okay, so r is 10 centimeters. So this is the new circle. Okay, and we're specifying by its radius, not by its circumference. But let's use the same amount of rotation. Okay, so now I've got a wheel, and the radius is what's known, and it rotates by 45 degrees, and I want to know the arc length. Okay, and theta is often a good general variable. This is Greek theta for an angle. Okay, and I want to know the arc length. Okay, well, it's just we can kind of do it in 2 steps now, right? So we're going to take that 45 degrees and we're going to compare it to a whole rotation. So it is this much of a whole rotation, which we know from the previous problem is 1/8. And then we're going to multiply it by the circumference, but that's 2 pi r. Okay, so now it's a little clunky. We have to do 2 things. We have to convert degrees to circumferences, but then also put in a 2 pi to convert radiuses to circumferences. Okay, and it's not ridiculously hard. That's 1/8 times 20 pi. It turns out to be 2.5 pi, very roughly like 8 centimeters. Okay, we just need to streamline this process. We're almost to radians. Trust me. Okay, so let's go back to, I want to go back to number 3 and remember how that was super easy. Number 3 was 40 centimeters circumference, and I measured in terms of circumferences, or in terms of full revolutions. And it was super easy. You just multiplied the two numbers. No 360s, no 180s, no pi's, no 2 pi's, whatever. You're done. I want to make it that easy, but where it's about radius instead of circumferences. Okay, so here the idea was we were measuring an angle. We did a smart thing. We measured this angle in terms of how much of a circumference it encompassed, and then it made it super easy. It all made it almost empty to ask, how long is this? The answer is 1/3 of a circumference. That's what I just told you. So it was easy by definition. And radians do the same thing, except it's just about the radius. Okay, so 1 radian. The idea is simply that 1 radian is 1 radius. Okay, so here's the idea of that. Here's what that means specifically in an example. Suppose I have, let's go back to this 10 centimeter problem from number 5, 10 centimeter radius circle, and I'm going to let that revolve, and I'm going to purposely let it revolve so that I go 10 centimeters. Then we call that angle is 1 radian, because how much it went over here is 1 radius. So something that involves 1 radius worth of travel is called 1 radian. So let's think about what that means. Let's see. Let's go back to something that was easy in terms of circumferentians. It's going to be just slightly messier in terms of radians. 1 revolution is going to be, well, let's see. This was 1 radius. Well, how much is that? Is this full circumference? It's 2 pi times the radius. So it's going to be 2 pi radians. When we measure one circumference in units of the radius, this equation just becomes this. Going once around the circle, 1 rotation, 1 full rotation is 2 pi radians. 1/2 of a revolution will be pi radians. Now, we might want to convert those to degrees as well, because we often do use degrees as well for these units. So 180 degrees is pi radians. Okay, yet another one. Well, let's go back to the 45 degrees. How much is 45 degrees? Well, we know that that's 1/8 of a revolution, so it's 2 pi over 8 or pi over 4 radians. Rad, period. Okay. That's plenty for this video. It's a little bit long, but I wanted to get the idea and talk about how it's pretty close to things that people come up with pretty naturally given their own devices. And then we'll practice more explicit calculations. But this is the heart of it. It's a new unit for angles or rotations, and it's just that 2 pi radians is 1 revolution.